All right, so let's do some ELE 115, Electronics for Technicians 2. And the subject of our kind of first non-review study this semester is induction. And so this is all about the connection between magnetism and electricity. So as you know, electricity, there's an electric field. If you have something that's got a lot of static electricity, you come near it, a spark will jump, or your hair stands on end, or you know, all sorts of things can happen. There's a lot of demonstrations out there where you take a ping pong ball and you make the plastic on it, you rub it with something to charge it up statically, and then you hold it near something and it's attracted, and instead of hanging the ping pong ball on a string straight up and down, it goes one way or the other. Well, that's an electric field. And what we have here is a magnet. This is a decently powerful magnet. It's from a microwave oven. And this might be samarium cobalt or just some kind of it's a ceramic, probably, which is part, iron powder and part ceramic, and they make a lot of materials nowadays to make, like speaker magnets, are made with ceramics very often. So what I want to show, this is our oscilloscope, and basically what you have here is, this is time going by here. The oscilloscope keeps drawing a line, and right now what I have here, let me see if we can get this thing. If you look at this thing right here, this kind of tubular thing, has a coil of wire in it. It's an inductor. And so we're talking about induction, and that's great. We're going to use an inductor, but it's just a coil of wire. It has no battery, no nothing, okay? But when I move wire, as you'll see in the book, if you've been reading the book, it says when wire cuts across the magnetic field, a current is induced in the wire, all right? Now they say a voltage is induced. I guess you can say that, but some current will flow through the wire, and that is an interaction between with the magnetic field here and the conductor. And so if you watch the screen up here while I go over this thing, you can see that we cause some spikes there, and you can see that we have the spikes are going back and forth, and the geometry here with this kind of planar magnet and this coil, if I just pass it one way, you'll mostly see say positive spikes. You see some negative there, but if I just pass it one way, I tried to do this before and I couldn't get it because of this geometry. I can't get it. So if I change the magnetic field, the way this magnet is magnetized, so here it seems to, no matter which way I go, it seems to give me a negative pulse first and then a positive pulse. Now if I change these wires around here, let's see what I get now. Now I get a positive pulse followed by a negative pulse. So switching the wires on the coil around will change the direction of things. Here we get a couple of pulses each time over. But the most important point here that I wanted to show is when you move a wire near a magnet, the energy in the moving wire cutting across the magnetic field induces current into the wire, and this is a bunch of coiled up wire in here. It's the wire kind of goes around in a helical fashion, like a spring. So now if I hold this thing still, Okay, but I moved the magnet past it. I get pretty much the same effect. I create pulses. Here, if I just hold it near the magnet but I don't move it, the static magnetic field doesn't do anything. I got to be moving, all right? And you can see I'm creating some pulses there. So that's an interaction between a passive wire and a magnetic field, and a magnet. So what I'm doing here is I'm putting in motion, let's see if I can do this right. I'm putting in motion and I'm getting out electricity. Now the other thing I could do, you can't really see my my power supply, but I have a 12 volt power supply here, and I'm going to hook this power supply up. Now this is going to be pretty subtle, so you have to watch closely on this. If I can even get the clip leads on here. And I believe what's going to happen here is I'm going to put current through this wire. Whoops, oh, sorry. I'm going to put current through this wire, and what I'm going to get out, so I'm going to put 12 volts on here. Let me put it down there. And let's try it again. Okay, not working at all. That's great. Let's try this one more time. I've done this before, trust me. And you can see it. The magnet attracts the wire, the metal that's in that thing. Now that actually moved a little bit. It's really hard to see. Let me see if I can get it so it moves toward the magnet. It actually moved up away from the magnet that last time. Let me see if I can get it to move toward the magnet. And here we are. Now I'm going to turn it on. Nothing. Okay, we'll keep trying here. And let's see if we can get anything to happen here. Alright, there was a tiniest movement. I could feel it in my hand, but it wasn't very convincing. Let's try it one more time. Yeah, there, I don't know if you saw it, but there was a tiny movement. We'll try it a couple more times. That was pretty hard to see. Ready? There's a little deflection there. Very tiny deflection. Let's see if it does anything if we do it this way. No. I guess I can feel it, but it's not really. Try two of these magnets, see if we get any better results. Yeah. Alright, one more time. Now, there's already a pull there, but when I put the current in, I believe it will increase. So let's watch that. Let's watch this guy right here and see if he does anything. He did bend down. I don't know if you can see it. Here, let's try this. We'll try to get a lot closer here. I hope you could see that. I'm going to do it again as soon as the power supply discharges here. Now let's watch it. There, that little movement down. Not very much in the way of scientific proof, but what it shows, just put this back here for now. Lab set up there. What that shows is if I put, I have wire and a magnetic field. If I put motion in, either in the magnet or in the wire, I get electricity out. That's a generator. If I put electricity in, I'll get motion out. That's a motor. Now, if I, had wound up something with a lot more turns of wire in it, so it interact a lot more positively with the magnetic field that's there, we would get a lot more movement. But I hope that in those the tiny deflections there, that you saw some movement. That was caused by putting current through that that inductor, creating its own magnetic field, and that magnetic field interacted with the magnet from the former microwave oven magnet. So that's all I wanted to say in this video. Is I'm trying to point out this interaction between magnetic, magnetism and electricity, and motion has to be involved in some of this, and you put in motion by moving a wire near a magnet or a magnet near a wire. You get electricity out, and that's generation. Waterfalls, you get water falling over a wheel, driving the wheel spins wires near a magnet or spins magnets near a wire, and you get electricity out, and that's a generator. If I take those wires and have them near the magnetic field, and I put current through the wire and apply a voltage to it, the electromagnet formed, the magnetic field around the wire will interact with the permanent magnetic field of the magnet, and I'll get motion, and that's a motor. So that's all we wanted to say with this one, and I hope to be back with another one on the nature of Lenz's law, and this idea that current through an inductor, inductors don't like current change. Inductors will change their magnetic field and do things as current tries to change. So that's coming up. All right, take it easy, and thanks for watching.